Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 10th, 2026, just 2 days ago. It proposes a fully synthetic generation pipeline that scales up to 1,000 diverse, code-driven environments for training autonomous agents. The paper is titled Agent World Model: Infinity Synthetic Environments for Agentic Reinforcement Learning. And as we'll see shortly, this approach not only improves scalability, but also leads to strong out-of-distribution generalization compared to traditional methods. And for those interested in the implementation, the authors have shared their code on GitHub. On Hugging Face, the 4 billion, 8 billion, and 14 billion parameter models are available. They feature examples for multi-turn tool use and agentic reinforcement learning. Figure 1 illustrates the three main pillars of the Agent World Model pipeline. On the left, it highlights that these are code-driven environments, meaning the agent interacts with executable software rather than a text-based simulation. In the center, the design uses SQL-backed databases to ensure state consistency, so every action has a reliable and permanent effect. Finally, the right panel emphasizes scale, offering 1,000 ready-to-use environments, which vastly outnumbers the limited sets found in existing work. Well, Figure 1 gave us the high-level pillars. Now, Figure 2 details the actual 5-step pipeline used to build these environments. It starts at the top with scenario and task synthesis, where the model takes simple seed names like Amazon or GitHub and expands them into specific user tasks. Moving to the right, steps 3 and 4 construct the machinery, designing the databases, and writing the Python code for the tool interfaces. Finally, step 5 on the left illustrates the training loop. Here, the agent interacts with these synthesized tools, and crucially, a code-augmented judge evaluates performance by actually verifying database state changes, ensuring the reward signal is robust. So, while Figure 2 outlined the pipeline, Table 2 here quantifies the complexity of the resulting environments. It lists key statistics across the generated set, such as the number of database tables and code lines. For instance, looking at the exposed tools row, agents have access to about 35 distinct tools on average, which creates a large and challenging action space. Below that, the environment code lines count shows each environment is built from nearly 2,000 lines of code, ensuring they are non-trivial software simulations. Finally, the agent steps per task average of 8.5 indicates that these tasks require long horizon planning to solve. Alright, since Table 2 showed us the complexity of the environments, Table 1 now breaks down the efficiency of creating them. It tracks the success rate, number of trials, and cost for each stage of the synthesis pipeline. Looking at the database and environment code rows, we see success rates consistently around 87 to 88%, which is quite high for automated code generation. The trial column is particularly interesting. Values like 1.12 show that the self-correction mechanism works almost immediately, rarely needing multiple retries. Finally, the bottom right shows the total cost is just over $57 for 100 samples, proving that generating these large-scale environments is economically feasible. So, having seen the efficiency in Table 1, Table 3 now compares the Agent World model against existing benchmarks like TauBench and MCP Universe. The reliance column highlights a major shift. While traditional methods depend on human annotation or real APIs, this pipeline requires only a list of names. Crucially, the SQL column shows it is the only method with a database backend to track state changes reliably. Finally, the number of environments column proves the scalability, reaching 1,000 environments, which is over 5 times more than the closest concurrent work, ENV scalar. Okay, now that we have established the scale of the environments, Table 4 reports the actual performance on 3 out-of-distribution benchmarks. Starting with the top section on the BFC LV3 leaderboard, we see strong gains. For the 8 billion parameter model, the overall score jumps from roughly 54 for the base model to nearly 66 for AWM. The middle and bottom sections, covering Tau Squared Bench and MCP Universe, confirm this trend. Crucially, AWM consistently outperforms the simulator baseline, proving that training in executable environments yields better generalization than relying on large language model simulations. Wrapping up, 2 takeaways stand out. First, synthetic, code-driven environments effectively solve the data scarcity bottleneck for agents. Second, using executable SQL databases ensures agents learn from reliable state changes rather than hallucinations. This paves the way for generalist agents capable of navigating complex real-world software. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.